Our last section is on scientific notation. There's a lot of slides coming up on scientific notation that'll explain it, but it'll all follow this same concept. If we have a number, any number, we're going to express it in scientific notation like this with some exponent. Maybe that exponent is a 5. Maybe it's a 17. Maybe it's a negative number like a negative 14. But it's always going to be expressed as some exponent. And this exponent is going to represent how far we moved the decimal. Okay. And you'll see that in a minute. So realistically, this is used in sciences more, hence scientific notation, but you'll see it to make really large numbers or really small numbers more manageable to write. So for example, if you have a really large number like the distance from the Earth to the Moon, you don't want to write that with 27 digits. So here we go. Let's say we had a number like this, 4.45100. 0, okay? And we could even add more zeros. We don't really want to write it that way, so scientific notation always works the same. You always take the number and then put a decimal place right after that first number. Never after the second number, always after the first number. Put the other non-zeros in, and that's it. Anything that's all the zeros you don't do. There's always a multiplication sign, always a 10, and then it's a matter of what the exponent is. Now in this case, in a large number, we don't really think about it, but in any number, the exponent is at the end. If you have any number with no decimal place, if you have any number, with no decimals, the decimal is at the end. So this is how we figure out the exponent. We say it is there, but in this number, it's here. So we ended up moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Therefore, this is to the exponent 11. Okay? So it's saying 4.51 times 10 to the exponent 11 because it represents how far the decimal's been moved. Now the other option is if we have a very small number, 0 decimal. 750 8, okay, something like that. Okay. Well, it's obvious where the decimal is, but we need to move the decimal all the way down here to the first non-zero. So 7.50. Whoops, that's an ugly looking 5. 508. Okay. Because we went to the first number that wasn't a 0, we put the decimal there, and then we just wrote the rest of the other numbers in behind it. And now we moved the decimal place. Well, it was here. It needs to go there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we moved it 9 places. But this is going to be a negative 9 because we moved it to the right. So we've actually made a very small number larger, and we compensate. Whoa! Anybody catch that mistake? What do we need? Times 10 to the negative 9. Okay? Now it's correct. Times 10 to the negative 9. Because for scientific notation, you always need the times 10. Okay? So, if you have a positive exponent, it means you have a really large number that you're turning into scientific notation. If you have a negative exponent, it means you have a really small number that you're turning into scientific notation. Right? Now, scientific notation will work with any number. It just doesn't make sense to do it with smaller numbers that are closer to 0. So for example, I'll get down here. If I said I had a 412, could I make that in scientific notation? Well, yes, I could. I could say that is 4.12, right? Because the 4 is the number, then the decimal, times 10 to the exponent. Well, it was here. I moved it 2 places. So I could go times 10 to the exponent 2, right? So you can do it with any number, but the reality is, why would we ever do it with numbers like this? Why would we ever do it with 412? We never would, right? So we use them for big numbers and small numbers. We don't ever tend to use it for numbers that aren't really, really large or really small, okay? I hope that makes sense. You'll get to see this video again in a few slides, but hopefully between this and all the videos, scientific notation makes sense, and you should see it in science as well.